Hello, welcome back to ClojureRank, solving another HackerRank problem in Clojure today. Let's take a look at the problem description here. There is an array of integers, a target value k, and we are asked to determine the number of pairs of elements in the array whose difference is equal to the target value. So in brute force terms, the n squared solution for every a in array, for every b in array, the absolute value of a minus b should be equal to k. And we want to determine the number of pairs of elements that meet that criteria. First off, I'll just go through the brute force solution and see what we get. I have a feeling that this is going to be one where we have to optimize, where there's going to be timeouts. But it's good to just solve for correctness first and then worry about optimization. This makes sure that we haven't missed any aspect of the problem and actually understood it correctly. So this gives us a seek of sets, and then I'm going to process that. The basic idea is that we're collecting pairs, and we're going to have one of these sets for each pair that differs by k, and we're going to. We'll also have the empty set in there, but there's only one empty set, so we can just drop that at the end. We're going to take that, and then we're going to flatten, count, decrement, and I think that's the solution. That is not the solution. Why is it not? What'd I miss here? Oh, it should be a set as well. Reduce conj into set. And then count and then decrement. And that's what it should be. I think that's it. I think that's the solution. But look at k can be, the size of k doesn't make that big a difference because it's still just subtraction, I guess. Maybe if this was some language that defaults to 32 bits, we might have an issue there. But yeah, and still 10 to the fifth is not a small number. So 10 to the fifth squared is a lot. So we may run into some performance issues with this. Let's see what we get. Yeah, that worked. Fingers crossed. Sometimes it's as easy as writing down the brute force solution. Not very common in these HackerRank problems, but in the real world, works all the time. Time limit, yep. Time. Loads, so plenty of them are correct, and I don't see any wrong answer, just time limit. So let's see what we can do with this instead of just iterating every single pair. So we're iterating the entire array, and at each iteration we've got A in the array, and we know that we want to find if there's a B. We want to find if there's a B such that A plus K is equal to B, or A minus K is equal to B. I have a math degree, so I think about sets all the time. There was a lot of sets. I tend to reach for them as one of my favorite tools. So I'm gonna try something involving a set. Once again, you're gonna see me do that a lot. Did we say they're all unique? They are all unique, so sets are a good tool to use here. So for each of these, there's two possibilities, either A plus K or A minus K. Sets in Clojure are functions, and they return the thing they're called with if it's in there, otherwise nil. Which is you can use as a Boolean. You can use as a Boolean to check for membership in the set, and you can actually return the thing itself as well. And then the other possibility, A minus K, the V is only defined inside of the whenlet. So there's a different V in each of these lines. And yeah, we get this for loop, and then we do the same logic to the result of that for, because it's still, it's not iterating the loop twice for every A. But it's still a seek of seeks. It's still for every A some sequence, and these are going to be either sets or nil. Whenlet, if this V is nil in the whenlet will return nil. So when we reduce everything into one set, all those nils are the same value, and then that's why we decrement at the end. Just a quick check that we still have the right number there. Cool, yep. And now let's try our new improved non-quadratic time function on the full test suite. Twest suite. Right on, looking good. So that's it. Reduce solves the problem pretty neatly. And the main thing was just not using the quadratic solution when a linear solution is available. Hope you enjoyed. If I missed anything, if you think it could be expressed more neatly, please leave a comment and let me know. Go ahead and click like on the video, subscribe so you hear about new videos when I come out with them. Going to be releasing these on a regular basis on ClojureRank, solving HackerRank problems in Clojure. Thanks for watching. Have a good day. Bye.